Welcome to this video that discusses ETL in the enterprise. After watching this video, you will be able to identify the purpose of the ETL process, explain the phases of the ETL process, identify the role of ETL in enterprise data operations, and list ETL tools and technologies. Let's consider the case of a marketing company looking to consolidate data from multiple sources into a single repository. The company generates vast amounts of data from disparate sources such as transactional systems, Internet of Things or IoT devices, CRM systems, and third-party vendors. The sheer volume, velocity, and variety of data make it challenging to derive meaningful insights without an effective data integration framework. The company needs to follow a systematic approach to harmonize data, making it usable for business intelligence or BI analytics, and operational applications. The process that combines data integration, analytics, and decision-making in enterprise data operations is called extract, transform, load, or ETL. It involves extracting data from varied sources, transforming data into a structured format, and loading data to a centralized repository. Let's examine each of these phases in detail. The extraction phase involves retrieving data from varied sources. The data could be structured, semi-structured, or unstructured. For example, structured data could be stored in databases such as Oracle or SQL Server, semi-structured data in XML files, JSON data, and log files, and unstructured data in emails and documents. The technologies commonly used for data extraction are database connectors such as JDBC and ODBC, APIs for real-time data access, and tools such as Apache NiFi and Informatica for automated data retrieval. Organizations might face challenges when extracting data because of source diversity and real-time needs. Source diversity challenges arise because enterprises often deal with heterogeneous data sources. Real-time needs challenges might arise when data has to be extracted from time-sensitive applications with minimal latency. The next phase is transformation. In this phase, raw data is converted into a structured, standardized, and meaningful format by following processes for data cleaning, standardization, enrichment, and aggregation. The data cleaning process removes duplicates, fills missing values, and corrects errors. During data standardization, data formats are converted to a consistent standard. Data enrichment involves adding value by incorporating additional attributes or context. The aggregation process summarizes data for high-level analysis, such as calculating totals or averages. Data transformation is performed using scripting or ETL tools. Scripting involves using languages such as Python, SQL, or R to perform transformations. ETL tools such as Talend, Informatica, and Apache Spark provide visual workflows and can be used for complex transformations. The main challenges in data transformation are maintaining data integrity while performing large-scale transformations and handling changes in source schema or structure. The last phase of ETL is loading. In this phase, transformed data is transferred to its destination. Depending on the enterprise's needs, the destination could be data warehouses, data lakes, and operational systems. Snowflake, Google BigQuery, and Azure Synapse are examples of data warehouses. Amazon S3 and Azure Data Lake are examples of data lakes, and real-time data feeding into CRM and ERP systems are examples of operational systems. The strategies for loading data include batch loading, incremental loading, and real-time loading. Batch loading includes periodic updates of large datasets and is suitable for historical or archival data. In the case of incremental loading, only the new or changed data is updated, reducing resource consumption, and in real-time loading, data is streamed as it arrives, enabling immediate use for real-time analytics. So, what is the role of ETL in enterprise data operations? In addition to data integration, ETL helps with data quality management, regulatory compliance, scalability, and enablement of advanced analytics. Let's look at each of these roles in detail. ETL acts as the backbone for integrating data from diverse sources into a single repository, breaking down silos across departments such as finance, marketing, and operations. ETL enforces quality standards to ensure clean, accurate, and reliable data. ETL processes ensure adherence to regulations such as GDPR or HIPAA by standardizing data handling and maintaining auditable records. Modern ETL platforms support distributed processing, enabling enterprises to scale as data volumes grow. ETL provides the foundation for advanced analytics, including machine learning or ML and artificial intelligence or AI, by preparing high-quality datasets. Some commonly used tools and technologies that facilitate ETL in enterprise environments include Informatica, Talend, Apache Spark, AWS Glue, and Microsoft SSIS. Informatica is a leader in enterprise-grade ETL with robust data integration capabilities. Talend is an open-source ETL tool known for its flexibility and extensive connector library. Apache Spark is a distributed processing framework ideal for handling large-scale transformations. AWS Glue is a fully managed ETL service that integrates with Amazon's data ecosystem. Microsoft SSIS is part of the SQL Server suite that provides comprehensive ETL capabilities for Microsoft environments. In this video, you learned that ETL combines data integration, analytics, and decision-making in enterprise data operations. The extraction phase of ETL involves retrieving data from varied sources. The technologies used for data extraction include database connectors, APIs for real-time data access, and tools. In the transformation phase, raw data is converted into a structured, standardized, and meaningful format. Data transformation is performed using scripting or ETL tools. In the loading phase, transformed data is transferred to its destination. The different strategies for loading data are batch loading, incremental loading, and real-time loading. ETL helps with data integration, data quality management, regulatory compliance, scalability, and enablement of advanced analytics.